let's go ahead and dive in. So welcome, folks. This is the Kubernetes Clinic on operationalizing Kubernetes for fun and for profit with Ignw. And you can go on here, John. Well, let's skip the poll for today. Go on to the next thing. So you want to introduce yourself first, and then I'll introduce myself?
Sure, thanks, Kendall. So, hey, folks, nice to meet you. John Wynkoop. I'm the CTO of Cloud and Cloud Native for Ignw. We're a full stack digital systems integrator, now part of CDW. Personally, I've been helping customers build and execute on cloud and cloud native strategies, distributed systems for the better part of 10 years. Currently focused on helping hybrid cloud adoption and containerization for our customers and leading digital transformation. Also a huge fan of SRE and agile operations, so you'll probably hear me pontificate on that for a bit.
And specifically, you primarily work with Kubernetes and not other container orchestration systems.
Correct. Correct. In fact, like are there other container orchestrators?
Hey, Nomad hit 1.0 like yesterday or something. So yeah.
Fair.
I don't.
Also, as a side note, I've been using Kube since it launched. So in version 1.0. So
nice.
Big fan.
Okay, and I'm Kendall. I'm president at Fairwinds. I've been at this company for coming up on 5.5 years, and we have been exclusively focused on Kubernetes for almost 4 of those. Is that right? 4.5 of those. About 4.5 years.
Right.
Been heavily focused on Kubernetes. Yeah. So excited to be here. Excited to talk about this with John, who I have known for a while and thoroughly enjoy. So go ahead, John. Real quick about Fairwinds. So we're a Kubernetes enablement company. Our focus is on helping anyone, anywhere in their Kubernetes journey. So we have services. That's for folks who are like, I need help with Kubernetes, get me there. And we will often build and maintain the entire Kubernetes-based infrastructure. We also offer some advisory for folks that are already using Kubernetes. We have a significant pile of open source because we're running Kubernetes at such scale for so many different customers. We see what the macro level problems are. We often write a open source tool to solve those problems. And we have a package around support for some of that open source as well. And then finally, we have a software product called Fairwinds Insights that is focused on configuration validation, where traditional monitoring is a fire alarm in your house saying, the house is on fire, put it out. Fairwinds Insights is more like a home inspector that's going to walk through your house and say, hey, it's not on fire yet, but there's gasoline everywhere and there's paper all around and somebody can zip line in through the upstairs and you didn't put any windows in your house. Also, you built 12 bathrooms with only 1 bedroom. Anyways, so that's where the software sits. It also handles policy enforcement. That's who Fairwinds is, but today's less about Fairwinds and more about Ignw. And John talking with us about best practices in Kubernetes. And John, you want to just go ahead and take it away? Maybe mention a little bit about who Ignw is before you.
Sure. Yeah. Thanks, Kendall. So Ignw, as I said, is a full stack digital systems integrator. We have a team of engineers that are focused on delivering cloud native solutions to customers, everything from helping with software delivery and software development to helping mature a DevOps and practice to helping automate existing infrastructure. Obviously, being cloud native and cloud first for a lot of our customers means looking at a container adoption strategy. And of course, when we talk about containers, we shortly then get to Kubernetes because it is, as we've said, kind of the de facto container orchestrator in the industry today. Now, doing tons of these deployments and managed engagements for our customers, helping customers adopt Kubernetes, helping them ship software to Kubernetes, we've kind of come up with call it a short list of best practices and things that you can look for, things to avoid, sort of a pitfalls. And that's what Fairwinds had asked us to speak about today, is just how would we help a customer who's just getting started on their journey to actually take this from something that's a toy and a science experiment into something that they can operationalize and feel comfortable running production workloads on. So the first one.
Wait, what? This big complicated thing that I, as an engineer, just want to fiddle with because I heard it's really exciting is a toy. Yeah, no, I'm just giving you a hard time. I understand. Like, there is that. Like, there's a lot of people who just want to mess around with it because they heard it's an important piece of technology, and that's as far as a lot of companies get, is fiddling around with it and seeing it as a toy. And there is a significant difference between running a Kubernetes cluster on a few of your Raspberry Pis in your basement because you think that sounds fun, and actually running it in production, particularly in a cloud or a database environment, and making it secure, reliable, all of those things. So sorry for
Agreed. Yeah, and obviously when we talk about how to leverage Kubernetes, managed Kubernetes, whether that's in your cloud provider of choice, whether that's Google Cloud or Microsoft, or I guess Oracle maybe has a Kubernetes distro. I don't know, or Amazon. But also then running that, how do we take that and run it on-prem? And some of the same lessons apply. Now, one of the things that we see with customers is as they move, and of course, deploying EKS, AKS, GKE, et cetera, becomes the next logical step after I've experimented with it, or even as part of my experimentation. So a lot of the practices on here we'll see are kind of covered by those managed distros. And that is one of the kind of the best practices to talk about up front is don't take on more than you have to and more than your company can comfortably do if you're going to turn this into a production deployment. Kube the hard way is a great learning tool. Don't get me wrong. I love that tutorial. I tell everybody to do it. If you do that to run it in production, you're wrong and you should feel bad. So, so first off, we want to talk about.
You have an opinion about it though, John? I think that's the part we're unclear about. You're wrong and you should feel bad, but how do you feel about it?
Yeah. So I'm obviously strongly opinionated about it, but so first of all, we're going to talk about just in general managing your clusters and what are some of the best practices we've come across for, in general, again, just the management of the cluster, not the nodes or the actual workloads. But so first thing we want to do is make sure that we're staying on the latest version. And this is kind of counterintuitive to anybody who's been in the operations space for a while. You always want to avoid the new version, right? Give it time to bake. Let somebody else find all the bugs. Well, with Kubernetes, especially as it's rapidly evolving, you want to be relatively close to the new version and you want to stay current. You don't want to take these giant leaps. And I'll use an example we ran into for a customer fairly recently with, I think we went from like Kube 114 to 119 or 116 to 119. And there was a breaking change in the API that they didn't catch because the versions that had deprecated that API were skipped. So in other words, they went from API is valid to API now that it was in the Ingress API, and the API no longer accepts the Ingress object that they had because they skipped all the versions where that had been deprecated and you would get the warnings. So that actually happens. The ecosystem is evolving quickly. So stay in relatively close to what is current. New versions are released every quarter. All of your managed providers and every major cloud are going to be shipping the latest version or close to the latest version relatively frequently. And so that's kind of our first recommendation is just stay current, and then you'll be better off. Also, and this doesn't just apply to deployments, this actually applies to your clusters as well. Figure out a methodology to do a rolling deployment, whether that's adding an entire pool of nodes with the new version and then rolling those in, moving all your workloads, and then turning off the old pool, whether that's rolling your nodes in one by one, et cetera. You really want to be able to make that upgrade. And this goes back to how do we make recommendation number one, usable? Well, you use rolling updates. You don't try to shut down all of your nodes and then bring them back up. You want to be able to roll new nodes into the cluster. Kubernetes supports this fairly simple. You just do a control plane upgrade, and the control plane upgrade it can be a hit list from a workload perspective. Once the control plane is on the new version, you start rolling in the new workers with the latest version. Again, there's lots of different ways to do this. You can bring in a whole new fleet of nodes, drain the old nodes, cordon and drain the old nodes, and then shut them down. In that case, we see that as a use case where we don't want to make a big bang upgrade. We may want to do it over some time, et cetera. The third thing we want to do about our cluster is secure the control plane. We have some recommendations. But
hang on a second, John. On the rolling updates to reduce downtime thing, I feel like an analogy of like, you can go to a bee colony, take out the old queen, put a new one in, and yes, there's going to be an adjustment period as they get there, but that's way less disturbing than taking all the bees out, moving them all to something else, those kinds of things. I mean, that's some of what you're talking about in terms of rolling updates, et cetera.
Yeah, I think I do think that's a good analogy, is rather than do like a blue-green cluster upgrade where I stand up a whole new cluster and then I try to migrate all of my workloads, you're better off to just do a rolling upgrade on your production cluster and testing that in a pre-production environment. Yeah, that's
Okay,
a good
sorry,
analogy.
keep going.
Nope, that's all right.
Securing the control plane.
Yes, of course, we want to also secure the control plane against unauthorized attack. The simplest way is don't make your control plane public. Limit, this is something that some of our cloud friends don't quite get yet, but your Kubernetes API probably shouldn't be available to the world. There have been documented vulnerabilities in the API. There have been that were fixed quickly, but still exist. There have been side channel attacks and in general information discovery attacks, all of which is against a perfectly configured control plane. Now, if we assume that there is one or two misconfigurations potentially in your control plane, just lock the control plane down. Make sure that you're using HTTPS, make sure that you're using solid encryption, etc. You just, again, and we have some more detailed recommendations on a follow-on slide here, but the takeaway is secure the control plane. Don't forget about it. It's not just the workloads that can be attacked. In fact, there's some really interesting work that I've seen done on essentially co-opting the workers in a cluster through an insecure control plane, using that to co-opt the workers to get shadow workloads running in someone else's cluster by dual registering them with a second control plane. So that's a thing that people can do, and then they can basically be stealing compute cycles from you if they can get access to your control plane.
Stealing compute. So why would somebody steal compute cycles from you, John? Just to mine Bitcoin?
Well, they could use it to mine Bitcoin. They could use it to run workloads in your environment to do reconnaissance or try to do data exfiltration. Remember that when a Kubernetes worker is in your environment, it is, even in a zero trust environment, it has an identity, and that identity has some permissions that come along with it. So, for example, if we're running in a COPS cluster in AWS, those worker nodes have an identity associated with them, and they have some level of elevated permission in the cloud environment. They may use that as a jumping off point for other attacks, may use it to get access to sensitive data. They may use it just to steal compute cycles.
Yeah. That's good.
So again, using namespace for simpler resource management, kind of, again, a no-brainer, but one of those things that we like to tell everybody, put your stuff in namespaces. Don't put everything in the default namespace. Arguably, you shouldn't have anything in the default namespace. This helps with RBAC. This helps with resource allocation. This helps with just generally all of the things that go into how to manage your workloads and manage your resources in your cluster. It also lets you segregate the cluster from an RBAC perspective so that you can isolate your development teams or your application teams so that they can safely deploy in a limited blast radius environment from other teams or from other applications. Of course, then that goes into, we start talking about how do we secure the cluster, how do we get better control. Then we want to leverage policies, so things like pod security policies, quota policies, et cetera. Things like how can we leverage an admission controller, like maybe with Insights, to prevent unauthorized or unsafe workloads from running, or even suboptimal workloads from running. And then, of course, the last one is, again, we're talking about how do we separate resources in the cluster. Then we can use node selectors to get physical isolation. So one of the things that we always see, everybody refers to namespaces as virtual clusters. That's kind of a misnomer. Namespace isolation inside of Kubernetes, while it's great and it has RBAC isolation, everything else, the workloads still run on the same nodes. So that you don't get a true virtual cluster unless you combine that with something like node selectors to run workloads on dedicated hardware or dedicated VMs. So we want to, again, for sensitive workloads, if maybe it doesn't quite justify another cluster, but you want it to run on its own environment, that's where a node selector would be really helpful. It also helps limit the blast radius of poorly configured deployments, where from a memory and resource utilization perspective. So things like putting your non-critical workloads, even if they're production, but they're not maybe non-critical or batch processing, putting them on a separate node pool with node selectors to prevent those jobs from affecting your production traffic. So again, as we talked about, using the latest version, every 3 months, Kubernetes has a huge distributed development team. It is truly hyperscale driven. So as I said, we had a customer who had a breaking API changes. Those aren't uncommon. They're not super frequent. It's not like every 3 months the API is going to completely fall apart on you, but there are pieces of the API that are under constant development. There's core functionality that's under constant development. Keep that in mind when you pin, so to speak, to a Kubernetes version. You're also, of course, and this is one of the reasons why a managed distro or a managed service like Fairwinds really makes a lot of sense for some customers, is there are compatibility challenges. There's a lot of moving pieces. There's etcd, there's the kubelet, there's Kube API server, there's all of the controller managers, there's all those different pieces in the Kubernetes ecosystem, and all of that has to be tested to work together. So by allowing your version to atrophy and by not staying current, when you want to take advantage of a new function, let's say a new load balancer, or maybe a new ingress controller, a new piece in the ecosystem that's available, that becomes a compatibility challenge now, because maybe that was built against a newer version of Kube. And again, this will probably stabilize over the next 5 years as Kubernetes becomes more stable and more less changed, right? There's less changes that are going to happen as the product matures, but I still, again, I recommend stay current. And then, of course, the version mismatch nightmare of trying to ensure that everything works together. Again, that goes back to why a managed distro might make sense. So again, as we said, rolling updates, use the burst capacity if you're running in the cloud. Mitigate the risk of failed patching by, instead of trying to patch a node, a Kubernetes worker or Kubernetes master, just roll in a new one. And if it doesn't work, roll it back out, right? So again, very similar to that, if we take that same immutable pattern we use in the container world, and containers are immutable, they should be easy to spin up and spin down, so should nodes in our Kubernetes cluster. It also helps us keep workloads available. Ideally, we're running workloads that have a replica of more than one, right? Ideally 3 or more. And we should then be able to seamlessly scale that workload up and then scale it down on the old nodes to really get that hitless upgrade we talked about. And again, these rolling updates, these don't have to be, I'm going to roll in, I have 100 nodes, I'm going to roll in 100 new nodes and turn 100 nodes off. This could be 1 at a time, 10 at a time, right? You have a lot of flexibility on this knob from a surge capacity perspective and a cost management capacity perspective. So just make sure that, go ahead.
Finish that.
Oh, I was just saying, make sure you're doing what's right for your team and for your cluster.
Yeah, I mean, the beauty of rolling in new things, shutting off old is really you're automating at scale somebody walking through a data center and turning all the machines off again and then on again, which, like, frankly, as good as our machines have gotten, they still need to be turned off and on sometimes. And like, honestly, that's a huge percentage of Kubernetes. What's the word I'm looking for? Just Q&A, right? Like when you're just troubleshooting. Troubleshooting is the word I'm looking for. You're just walking through and shutting the machine off and turning it back on, and 60% of the time it works every time.
Nice. So again, as we said, there's some best practices around securing the control plane too. And most of this does not rely on turn it off, turn it back on again, although that's probably on the list somewhere. But as you can see, this, and actually StackRox did a really good job of kind of summarizing some of this. And there's the link down there in the bottom that kind of summarizes a lot of these best practices. But yeah, it's, first of all, disable profiling if you're not using it, right? Turn off things that you're not using in the API. And that you'll see that same disable profiling across all of the components. But turn off insecure authentication. Make sure that you're using HTTPS. Make sure you're using trusted CAs. These aren't new concepts. These are things that we as IT practitioners should have been doing from the start. Kubernetes is no different. We still need to make sure we apply these good security practices to it, right? It's not reinventing the wheel. It's just understanding where all of the pieces. This goes back to Kubernetes being a complicated and lots of different components to it, right? There's a lot of places you have to make sure that you're doing this. So again, just some best practices, and the StackRox post there does a really good job of walking you through how to do all of these. Some of the, I'll just cherry pick a couple of these that are not always intuitive. So always pull images is one that we get a lot of flack from some customers on. They say, why would I want to do that? That's going to result in a ton of data transfer. And the answer is that if you're using cached images and your development teams have a life cycle that uses a tag that rotate that doesn't that moves as the image moves. So for example, latest, this can become an issue, right? So if you're doing a tag and immutable tags on your container images, like you should be, putting a SHA hash on them or something else and using that doesn't really matter. But if you're reusing tags in your container registry, you always want to make sure you're pulling the latest version of that image from the registry, so that as patches or updates are made to the image in the registry, those are getting applied to the running containers in the cluster. Same thing for don't use the always admit admission controller is kind of the de facto one. You want to have some controls around what workloads are going to run in the cluster. So again, namespace usage, again, focused on how do we manage the cluster? How do we manage logical grouping of resources? So namespace usage is going to give us logical grouping, namespace isolation, RBAC. It can't, however, provide things like affinity or geographic limitations. So namespaces aren't going to help me solve the problem of make sure that I'm running this in the US only or in the EU only. It's also not going to help with resource isolation, as we talked about. That's going to be something that we can do with node selectors and node pools, but it's not going to help. Namespaces won't help with that. It also doesn't provide complete opaqueness. In other words, just because you're running in a namespace doesn't mean you're running in your own isolated world that nobody else can see. There's service discovery that can happen cross namespace. There's some artifacts that are still visible in the Kube API to certain workloads within the cluster. So don't assume that your namespace is completely isolated from the rest of the cluster and is a black box that nobody can see into. If you need that level of isolation, we highly recommend a separate cluster with a separate control plane and separate RBAC policies.
Which is significant when you're talking about multi-tenancy. And if you have customers that really need to feel like they are multi-tenant, and that's it's pretty easy to get to a point where you're using Kubernetes to stand up Kubernetes clusters, and then you've basically built an EKS or a GKE. But sometimes you need that, and the latest CVE for Kubernetes was all related to multi-tenancy and security.
Yep. Yeah, and so multi-tenancy in Kubernetes isn't quite there yet. Multi-tenancy in containers in general isn't quite there yet. Where if I was a bank with 50 billion in assets, I would feel comfortable running multiple isolated customers in the same cluster if they have access to the Kubernetes control plane. Now, if your customers are just using workloads running on Kube and you're the one managing all of the deployments, all of the applications, you're owning the Kube cluster and you just need some multi-tenancy and some isolation, I think that there is some there's definitely some use cases there for putting each customer in their own namespace, using network policy, et cetera. Where we don't want to use namespaces, for example, is in those anti-patterns. So number one, and this is one we see all the time, I'm going to put every version of my software in a new namespace. No, don't do that. That's terrible. What you should do instead is use rolling updates for your software and allow Kubernetes, whether it's through a Helm chart or whether it's through your deployment directly, to manage the life cycle of your application. If you need to have a canary, for example, or a blue-green, you create a blue and a green, but you don't create blue 1.0, blue 2.0, blue 3.0, and continue to increment that and deploy an entire new copy of the stack into a new namespace. That defeats a lot of the functionality that you get from application lifecycle management out of the Kube API. The second one, and we just talked about this, is PCI, right? Well, we kind of talked about it, alluded to it. I tell people that, right, as of right now, Kubernetes doesn't have a sufficient isolation in namespaces to give you PCI compliance. What's going to end up happening then is that namespace isn't the only thing that's in scope. Your entire Kubernetes cluster is going to now be in scope. Don't just put your PCI stuff or your HIPAA or SOX or whatever your regulatory requirements are. Put that in its own Kubernetes cluster that is part of the regulated environment, because even if it's in its own namespace, even if it's on its own set of nodes, it still shares a control plane, it still shares networks, it still shares firewalls and load balancers and RBAC and. So, and the last one is, again, geographic limitations, EU, US, Asia. If you have like GDPR that says, my data must reside in the EU, don't rely on a namespace. Now, obviously, you'd have to have a multi-region cluster to do that anyway, where your control plane span multiple regions in your provider. That's already an anti-pattern. You're right. We don't recommend the control plane be split across multiple regions. There's a lot of failure modes that don't work well in that case. Even if you have 3 regions that you can span across, we don't recommend the control plane span regions. We want everything to be kind of tightly coupled, not the least of which is data egress. Your data egress charges in that case alone are going to kill you. So again, just don't think of namespaces in that way. Just think of them more as team-based isolation. And if you have clusters running in multiple regions, there are options. You can use something like Flux or a commercial product like Anthos or OpenShift to get namespace synchronization between those clusters, where the user will have, the developer will have the same experience, the same namespace, the same rights on every cluster, but they will still need to connect to each cluster individually.
Well, and to be clear, those are anti-patterns and things you suggest against. It's not
Correct.
that they can't be done, it's that the complexity involved in doing them right is probably not worth the shift, the lift.
Agreed. Yeah, they're technically feasible, but
practically not.
Practically, yeah, but practically they're not a great idea. So lastly, I think we're going to talk about policies. So some of the policies we recommend is put limit ranges on your namespaces, put resource quotas out there, use a pod security policies to prevent things, what we like to call foot guns, which are things like my container runs as root, my container has a read-write file system, etc. You can also use pod security policies to set up SE Linux, AppArmor, or whatever your flavor of the day is for your app security contexts. So really helpful with again, we talk about that multi-tenancy, right? We've seen customers that will use SE Linux or AppArmor to wrap those customer-facing workloads and provide that additional layer of kind of security in the pod that helps with the isolation that containers don't quite bring to the table. So and of course, you want to restrict network and volume access where possible. So things like make sure that you're restricting who can access what types of volumes, who can access the network. You've used network security policies, et cetera. That's where we start to get into network policy and how do we use distributed firewalls. We say ish because network policy is, depending on the implementation, depending on the CNI, is using network policy to program distributed IP tables firewalls. But it gets kind of convoluted, especially if you start with a default deny all policy. That's why we've seen the expansion of things like Aqua and Twistlock coming into this space and trying to provide assistance in this micro-segmentation world. One of the key takeaways, and this is something we always hear from customers, is, oh, Istio solves for this. Just to be clear, Istio does not solve for layer 3 network isolation. It helps, right? And it especially solves for layer 7 network isolation because we have proxies and we can use MTLS and everything else, but it does not solve for layer 3 network isolation. So just because you're running Istio doesn't mean you don't need network security policies. They're best when teamed together. And then of course,
and even if you're running Istio, it doesn't mean you know how to do this.
Fair. And then, of course, you want to restrict your API objects and it's what network API objects users can access and pods can access. The key takeaway, though, is your CNI has to support this. And not all CNIs are created equal, whether you're using the CNI that's native to your cloud provider, whether you're using a CNI like Weave or Flannel, or whether you're using a hardware CNI like Cisco ACI, you have to tailor your network policies to what capabilities your CNI can support. Again, we talked about node selectors. The big takeaway here is that workloads are created different, and what we like to affectionately refer to as cluster geometry matters, meaning if I have a bunch of RAM heavy workloads and a bunch of CPU heavy workloads, I might be able to stack those onto the same nodes. But if I have 10x the RAM heavy workloads than I do CPU workloads, I want to make sure that I have resource pools that are optimized for running each of those types of work. So I don't want to put something that takes 4 cores and 128 megs of RAM on a node that has 5 terabytes of RAM, or I'm just obviously make that up, but an immense amount of RAM, right? A terabyte of RAM in 16 cores or 32 cores, because I'm quickly going to run out of schedulable cores well before I run out of RAM. So you want to make sure that you use node pools intelligently to provide isolation, support things like additional NICs or GPUs or NVMe or those weird hardware things that you may need for workloads, but also just the right amount of CPU and RAM, the ratio of CPU to RAM. In most clusters, we find that we can help customers find the right blend. So it's usually about 2 gigs per core of RAM. But obviously that's on a case-by-case basis. That's something that your ops team or your SRE team really needs to evaluate for your workloads. So let me start. That's great. We talked about the cluster. Go ahead.
Isn't that a thing you can leverage the vertical pod autoscaler to help you get right?
You can, for sure, use VPA to help. The challenge becomes summarizing that VPA data across large deployments. So
Sure.
VPA is very good at telling you what a specific pod needs. It's not so great at telling you what 1,000 pods need and aggregating that data. So that's where you can leverage some third-party tooling. I think Fairwinds has Goldilocks available as, for example, as an open source tool that can help with that. But whether you do that through your traditional monitoring tool, something like Datadog or CloudWatch or Cloud Monitoring, or you do that through something that's more Kube native, it is something that has to be done. It's the Kubernetes isn't going to do it for you. Even the providers that offer automatic node sizing still miss on that because they ultimately they don't know what tomorrow looks like, right? They base everything on what you have running today. And so if you know that you're going to spin up, like let's say you're a retailer and Black Friday is coming up, and you're going to spin up, 400 more web front ends tomorrow to meet the demand. You have to know that that's coming and make sure that those nodes are available. Otherwise, you're going to see a performance impact. Now, you may recover from that using the automated tooling, and that's where a lot of that automated tooling is fantastic. But still, understanding your workloads is key, and being able to plan and do capacity planning. So it's great. Actually, that's a great segue into workloads, right? And what we call deployments. So we'll run through these real quick, and then we have a slide for each one in more detail. But key takeaway: don't use naked pods. Use replicas. Abstract your configuration away. Allocate resources to the scheduler. And then use probes, resource requests, liveness and readiness probes, and then terminate gracefully. And these are things that we see a lot of people miss. So naked pods. If you're not running deployments, if you're running actual pods in Kubernetes, stop. Wrap them with something. I don't care if it's a deployment, a job, a daemon set, a stateful set, something. Wrap them with something, because pods are mortal. They will die. Kubernetes will not restart them. That's kind of in the nature by their very definition. That's how they're designed to work. The idea here is that I can set replicas and allow the Kubernetes scheduler to do its job in my deployment. So with a deployment, I can say, I want 3 copies of this running, and I don't really care where they run or how they run. Go forth and make it happen. And Kubernetes will take that declaration and make it reality for me. And if something fails, it will fix it. It'll actually restart the pod. So it makes our app more resilient by its, and we let Kubernetes handle a lot of the heavy lifting there. By that same token, though, we need to make our app stateless, so that when our app has to be restarted, it can be. Now, I'm not delusional where I think that every app is completely stateless. So stateful sets were introduced to solve this problem for you. You can, of course, use stateful workloads in Kube using a stateful set and tying them to persistent storage. However, we want to minimize that. If you don't need state, don't use state. If you're not storing persistent data, and if you can, especially if you're running in a cloud like AWS or GCP or Azure, leverage a managed data store to stop from having to store data. Don't run Postgres in your cluster if there's a managed Postgres offering available for you, right? There's a huge point of diminishing returns on building stateful infrastructure when you have a provider that's already got an SLA that's committing to keeping that data available for you. And by that same token, we want to leverage selectors so that as those pods come and go, as they get added and removed, they automatically get added to our backing services. Label selectors are a great way to do this. That's typically kind of our go-to for pods. But you can get creative with these too. You can use selectors with versions. You can use selectors with front end, back end. You can use, you don't just have to say, this is my app and it ties to this service. You can actually have multiple services fronting the same set of pods or a similar set of pods. And those services can have, for example, different percentages of traffic going to different versions of your service. So it's where we talked about not using namespaces. Labels are a great way to differentiate versions in your service. That's honestly kind of the preferred method for differentiating versions in your service. And then when we start talking about adding on things like a service mesh, we can leverage canary deploys and incremental routing and all the functionality we get with something like Mixer. And lastly, how do we control the life cycle of all this? Again, rolling updates, right? Don't do mass, big bang updates. Roll in new pods gracefully. Monitor the traffic to make sure that those pods are healthy before we cut everybody over. Don't just flip a big switch and cross your fingers and hope that everything goes well. You have some knobs that you can control your rolling updates. You have the ability to limit max surge. What that means is how much capacity will Kubernetes, additional capacity will they go over, kind of what the baseline is when rolling in new pods. This is helpful if you have very large deployments. So let's say 4,000 or 5,000 pods running in a cluster, and maybe a couple hundred of those are for a given application. I don't want to roll those in one at a time. It's going to take all day. I also don't want to roll those in 400 at a time, right? So I need to find a good middle ground where my deployment's going to happen fast. I'm going to get some useful data out of my rolling update, but I'm not just going to triple the size of my cluster. And then again, max unavailable slows our rolling update. So that controls, if we use max surge and max unavailable together, we can get really granular control over how fast we roll out a new version via the rolling update mechanism. So one of the key takeaways from using deployments, of course, is that we now want to make sure that we're pulling the configuration out of that deployment so that it's reusable in every environment. This also helps with leveraging the same artifact through dev test prod. So config maps and secrets are kind of the de facto way to do this. You can also leverage something like Vault or KMS or Secret Store to get the data. But the idea is separate the configuration from the application, right? This goes back to the 12-factor app, right? Your app should be consuming configuration via the environment. Just because you're doing this doesn't mean that this is now a free-for-all. You should treat the configuration the exact same way you treat the application code. Version control it, back it up, keep it in Git, right? But it does allow you to limit the changes on deploy. So you can deploy the configuration separately from the application, which means that as the environment changes, you don't necessarily have to redeploy the entire app. You can change just one line of configuration and then do a rolling restart or rolling update of your pods. Your apps should get the config from the environment. Don't use files baked into your containers. Don't inject files if you can help it. Obviously, we understand that happens sometimes. If you're going to inject files, pull them from a config map. Use either a init container, a sidecar container. Use some kind of pattern to not inject them into the container, but inject them at runtime. So at runtime, your configuration should get mixed with your application. It shouldn't be something that's baked in from the beginning. And then, of course, one of the things that we highly recommend is combining all of this with service discovery to limit the configuration you have to make. So Kubernetes has a great built-in service discovery mechanism, service name .namespace.svc.cluster.local as one example. You leverage that, right? If you have a backend service and a front end service, when you need to reference your backend service, just call it backend, this name of the service, and put that in the environment variable. What that means is that as you move that service through production, through your lifecycle, rather, through dev, test, prod, your application will be able to move seamlessly between those environments without a configuration change. So then we talk about liveness and readiness probes, and it looks like Kendall might actually be failing his liveness probe. So
why? Well,
there he goes. Oh, never mind. Just took a couple seconds.
Was my video paused, or you just thought that?
No, you just weren't moving. The fan was still moving. You weren't.
Yeah, well, my bad.
No worries. But the two takeaways here is that liveness probes are what Kubernetes uses to determine if the container is alive and healthy. Meaning, do I need to kill it and restart it? Readiness probes mean should I accept traffic? So your readiness probe is really what we use to control when the pod is sent traffic and when the pod starts draining traffic. Liveness probes are health checks, right? Oh my gosh, it's dead. I need to restart it now. So One of the big mistakes we always see users make is fail liveness probes early on. So your liveness probes really should not be the application is up and ready. They should be the container is doing something. If you fail liveness probes when your application is not ready, your containers are going to get, you're going to get a ton of churn in your container. If the application is coming up, for example, and starting, that's fine. Like just don't fail your, fail your readiness probe, but not your liveness probe. We have some examples in here, but essentially these both support HTTP checks, exec checks, and TCP socket checks. Typically, your readiness probe is something you can easily do with a HTTP check. Liveness probes, oftentimes an HTTP check will work, but oftentimes you'll need an exec. I don't usually recommend TCP socket as a go-to for these, primarily because your application may still have a socket open, but may be dead. And especially we've seen failure modes where applications don't close the socket and the container's still running. Of course, all of this assumes that something inside the container is hung and the container hasn't exited. If the container's exited and it's actually, whether it's an exit 0 or exit 1, the Kubernetes will see that as terminated and it will restart it. So this is assuming more of a hung state. And then lastly, we want to make sure we terminate gracefully. This is a big one that we see application teams miss on. And it's not intuitive because it's a little different from what we're used to in the sort of the more server-based world. But remember, your pods are mortal. Your service will die at some point in its life. Just your regular, whether it's a Kubernetes upgrade, whether it's we need to rescale the cluster, whether it's just some scheduling adjustments, that you have to assume that your pod is going to get told to stop and restart. That's okay. Like we need to handle that as a developer. So
I think it's important to say too here, like everybody knows that every computing system eventually goes down. What's different about this is you're never going to have a pod that you're going to be able to point at and brag to your friends, hey, look, lifetime uptime is at 15 years. Like that's not a thing that happens in Kubernetes, right? I mean, in the old sysadmin days, everybody had that box that they were proud of. This one's just never gone down, right?
Right.
And but in this whole world, everything is built to be ephemeral from the beginning. And as a result, a long-lived service might make it a few months if you get really lucky, and that's going to be unusual. So like we're talking a very different lifespan.
Yeah, and and just resetting that expectation is key, right? Not only from a developer perspective, but from an operations perspective. To your point, I've been that guy. I mean, I've been the one who said, "Look at my Linux box over there. It's been up for 7 years. Isn't it great? I didn't even have to patch it." That's to your point. That's not going to happen in Kube. It's just not, right? Version upgrades happen, scaling events happen, pods die, and we shouldn't expect it to happen. We shouldn't expect our pod to live more than a couple of days or weeks. And so we just plan for that up front, right? So we know we're going to get a sig term from the scheduler, and that's and we will get a sig term. So we'll get sig term. We need to handle that in our application. If we get sig term and we just crash, why bother sending sig term? Just send a sig kill, right? And then we die. So use sig term to terminate gracefully, use sig term to be intelligent, and then the scaling events won't matter. What I mean by that is as soon as you get a sig term, start failing a readiness probe. Tell Kubernetes, don't send me any more traffic, right? Step one, cool. So now we've gracefully said any new connections are going to go somewhere else. Finish the work you're doing, right? Gracefully end your user sessions, finish what you're doing, terminate all of those sessions, close all that work, and then terminate. It's a very simple kind of, again, this is best practice with a VM behind a load balancer as well. Just be graceful about it, drain your service and then terminate gracefully, and the user won't even know that pod went away. There are some, and a lot of times we'll say, well, my service could take 15 minutes to finish what it's doing. There are knobs you can turn inside of Kubernetes that adjust the delta between sig term and sig kill. You can have Kubernetes wait 15, 20, 30 minutes before killing pods that it sent sig term to. So those knobs exist in the control plane that allow you to give you the flexibility to tweak this to improve the user experience. So that was a brief summary of some of the things that we've seen. I think From a biggest challenges perspective, I'm gonna answer this one first, right? What are the biggest challenges I've seen to deploying Kube? Number one, it's paradigm shift, right? It's completely different from an operator perspective to what we used to. We used to think that VMs were, at least in all but the largest scale, they were important. We gave them cute names. We told them that they were wonderful little lovely, important VMs, and that ultimately they're not, right? They're just a fleet of resources that should be fungible and replaceable at will. And so that mindset was really a big change for us, which of course then led to some challenges. And looking at the poll here, right? Basically that's complexity. From my perspective, right? It's just, how do I handle this new complex environment? So
yeah,
that was fine.
Well, and complexity isn't, Linux is complex, but if you've used Linux your whole life, the complexity doesn't overwhelm you. If
Right.
all you've ever used is Windows and you switch to Linux, the complexity feels drowning, in the same way that if all you've ever used is an iPhone and you switch to Windows, you're going to be shocked at the complexity. It's, part of it is the lack of familiarity, and that it is a whole new paradigm.
So complexity is relevant?
Maybe that's the way to say it.
I mean, arguably, and this is one of the things I always tell our customers when they say something is complex. They say, "Oh, that's super complex." And, well, you know what else is complex? Driving a car.
Yeah.
If you handed a car to somebody who had never had any concept of it, all the rules you have to follow, all the machinery, you've got to turn the key, you've got to use these sticks, you've got to push these pedals, you've got to turn this wheel. It's about managing the complexity. It's about learning to drive. Just like Kubernetes is about learning to drive, right? Understand the paradigm, get education, get your teams comfortable with the environment, get them comfortable with the paradigm shift, and about what complexity you're going to outsource and what complexity you're going to take on.
Okay. Yeah, and the top answers from the poll are getting to production, security, and performance. And thank you, John. You can move on to the next slide here, and we'll wrap things up. But appreciate the depth of that. That's great. And for clarity, this will be made available as a recorded video later on as well. So coming up January, we have another scheduled Kubernetes Clinic with Instacluster. There will probably be more that follow after. Look forward to that one. So one more slide I think we've got. If you want to take a look at your own Kubernetes environment and how you're doing with it, Fairwinds has this free Kubernetes. Download that paper and kind of go through and have a feeling for how well you're doing. Yeah, well, thanks so much for being with us. John, appreciate you doing this with us.
Thanks everybody for your time. Kendall, thanks for having us.
Another Kubernetes Clinic in the future. Thanks.
Definitely. I'm looking forward to that one in January. I think it's going to be interesting.
Instacluster will be interesting.
Cool. All right. Well, thanks everybody for your time. Everybody have a great day.